A lepton is an example of a fundamental particle. State what is meant by a fundamental particle. Okay, so they said a lepton is an example, meaning that there might be other fundamental particles, but a lepton is an example of a fundamental particle. It's an example, meaning that there can be other fundamental particles. So a lepton is an example of a fundamental particle. State what is meant by a fundamental particle. A fundamental particle is a particle which cannot be broken into anything smaller. So once you have a lepton, you cannot break it into smaller objects. In other words, it is not formed by combining other objects to form it. That way also it cannot be split into smaller objects. So that's why it's a fundamental particle. A lambda particle is a hadron. Remember, we have a class of subatomic particles called hadrons. It's either hadrons or leptons. Hadrons are not fundamental particles because hadrons are made up of quarks. Quarks are fundamental particles because they cannot be split into smaller particles. But quarks combine to form hadrons. So hadrons are not fundamental particles. So a lambda particle is a hadron that consists of an up quark, a down quark, and a strange quark. So by seeing this, it should be clear to us that a lambda, this hadron, is under the class of hadrons called baryons, because baryons are the ones with the 3 quarks. Sure that the charge on the lambda is 0, so we just need to do the addition. So remember, it's an up quark, down quark, and a strange quark. So an up quark is a charge of plus 2 over 3e. A down quark, just like a strange quark, because remember, up top charm, those ones have plus 2 over 3e, whilst down bottom strange have minus 1 over 3e. So an up quark here is plus 2 over 3e, a down quark is minus 1 over 3e, a strange quark is minus 1 over 3e. So when you add these charges, actually what was happening here was addition. It's just that I didn't want to waste time writing plus here. Actually it was addition. So it was more like addition, but adding something, but with brackets there, adding something, but with brackets there. But the plus and the minus becomes minus. So ultimately it becomes as if we are subtracting. But in reality, we're adding the charges, and after adding the charges of the up and down and charm and strange, we got 0. So we have proved that the lambda particle is a charge of 0. The lambda particle is unstable. It can decay into a neutron and a pion as shown. So as you can see there in this reaction, it is decaying into a neutron and a pion. Okay, fine. The pion particle consists of an up quark and an up antiquark. So the pion particle is made up of 2 things, an up quark and an up antiquark. Compare the properties of an up quark and an up antiquark. So we have 2 things here, up quark and an up antiquark. So we are considering an up quark and an up antiquark. We want to compare. So there are so many comparisons we can make. Comparison does not mean that we are talking about the differences. Comparison can also talk about the similarities. So for example, an up quark and an up antiquark, they are antimatter of each other. Okay, but so they've got equal mass. That's the first thing, they've got equal mass. Number 1. Number 2, they've got equal magnitude of charge. So the other one might be the up quark might be plus 2 over 3e, but the anti-up quark will be minus 2 over 3e. They've got equal magnitude, 2 over 3e, even though the charges are opposite. So they've got equal magnitude of charge, equal mass. They're also both fundamental particles. Quarks are fundamental particles, all 6 of them. Quarks are fundamental particles that makes up hadrons. They've got opposite sign of charge. Now we are talking about the differences. they've got opposite sign of charge. The up quark is plus 2 over 3e, whilst the anti-up quark is minus 2 over 3e. Then one is matter, the up quark is the matter, then the anti-up quark is the antimatter. Okay, so we have compared. Explain why the neutron is classed as a baryon and the pion particle is classed as a meson. So the question is asking you, why is it that the neutron is classed as a baryon and the pion particle is classed as a meson? Now the neutron, you must understand that what makes a neutron a baryon is very simple. A baryon are a class of hadrons, just like mesons are a class of hadrons. They are both made up of quarks, mesons, and baryons. But what makes a neutron a baryon is the fact that it is made up of 3 quarks, whilst a meson, the pion, is a meson because, as we are told there, it is formed up of an up quark and an up antiquark. So a meson is a pion is a meson because of that. So a pion is a meson because it consists of 1 up quark and 1 anti-quark.